Alright, so really quickly I want to touch on two things that I neglected to discuss in the last video. First, you might have some questions about these elements down here. Depending on what version of the periodic table you have, these elements might be filled in. They might be filled in with actual names, or they could be filled in with things like UUQ or UUB, kind of placeholders. This specific periodic table just has the atomic numbers and the atomic masses in parentheses. Okay, so these elements down here in this area aren't naturally occurring. Okay, they are man-made. They are very unstable. Typically, they're very short-lived. They decay pretty quickly. So a lot of tables don't write them in. We don't deal with them very often, if ever. Some older tables have placeholders, the UU with another letter, to show that it's been predicted the element can exist, but it hasn't been created yet. Once it is created in a lab situation, it typically is filled in with a name. So if you see those on periodic tables, don't worry about those down there. We won't deal with those. The reason that it has the reason that it has a molar mass or an average atomic mass in parentheses and is always a whole number is because it's not an average atomic mass. It's just the mass of the most stable isotope, so the most long-lived isotope of that species. So that might answer your question. Other than that, we really don't worry about this little last row of the periodic table down here very often. The one thing that is very important is I want you to go to the periodic table that you're going to use for the whole course, the one that you'll commonly get your masses from, and highlight these elements: nitrogen, oxygen, chlorine, bromine, iodine, and then hydrogen. Okay, so if you'll notice, I highlighted 7 elements, and 6 of those 7 elements kind of form the number 7. Okay, so it's a good way to remember it. These 7 elements are what we call diatomic. Okay, so what that means is you will never see these 7 elements by themselves. So you will never see just O, oxygen. It'll always either be in a molecule like H2O, or if it is just oxygen by itself, it'll be O2. Okay, for chlorine, you'll never see just Cl by itself. You'll have Cl2. Okay, for bromine, you'll have Br2. For H, you'll have H2. For I, you'll have I2. For F, you'll have F2. And then for N, you'll have N2. Okay? So that doesn't mean in molecules that you'll always have 2 N's or 2 F's or 2 I's. All this means is when that specific element is by itself, okay, and it does not have a charge, so it's just an atom by itself, it'll always be bonded to itself. So there'll always be 2 of these specific elements bonded together. So from this point forward, if I ever reference bromine, okay, and I say 1 molecule of bromine, I mean Br2. 1 molecule of chlorine, Cl2. So when we look at the molar masses of just chlorine molecules, we'll have to do 35.45 times 2. Bromine will be 79.90 times 2. Okay, so we take the mass of the actual diatomic molecule there. Okay, so go ahead and commit those to memory. I told you to mark them on the periodic table, but, whoops, sorry. So it should be when you hear those molecules, though, you automatically know, okay, that's diatomic. Okay, so don't forget about those.